In this tutorial, you will learn about the object class in Java. You will learn all classes are a descendant from the object class. You will learn how to override the equals and toString methods inherited from object. As we learned earlier, at the top of the hierarchy, object is the most general of all classes. Classes near the bottom of the hierarchy provide more specialized behavior. You do not need to explicitly extend the object class when writing your own classes. Classes which do not extend another class automatically extend object. The methods inherited from object are passed along the classes further down in the hierarchy chain. Let's look at the Java API for the object class. As stated, class object is the root of the class hierarchy. Every class has object as a superclass. So every class you write gets the implementation of these methods from object. Some of the methods we're going to want to override in our own classes. These include the equals method and the toString method. So let's look at the equals method that we'll be overriding. If we don't override equals, then we get the default implementation from the object class, which just compares references. So the reference of one object is compared to the reference of another object. So really it's just testing to see if they're aliases. So here's the default implementation of toString as written in the object class. So in my own classes, if I don't override toString, when I print my object, what will be printed is the name of the class, the @ symbol, and the hash code of my object. So let's look at those methods in more detail by writing a class that represents a box. So here's my class header, public class box. Notice I'm not using the extends object. I automatically extend object when I don't extend any other classes. So my box class will get all of the methods that are written in the object class. For my implementation, boxes have a length, width, and height. When I create a box, I'm going to pass it the length, width, and height. My instance variables will be set to these passed values. In this example, my length, width, and height will be integer values. In class, you'll be writing your own box class, which will define length, width, and height as doubles. You're going to have to do a little extra work when comparing those values, so we're just going to keep it simple here and define them as ints. So now let's write a method to calculate and return the volume. Since all my variables are of type int, then the return type will also be int. Okay, there's our box class. Notice that I'm not writing a toString method or an equals method. So let's write a driver class and test our program. So now that my objects have been created, I can run the equals and toString methods that have been inherited from the object class. This statement prints the result of B1 running the equals method and is passed B2. Well, I know object just compares references, so this should return false. In this statement, I'm going to ask B1 to run the equals method and pass it the address to B3. Now I would expect that those two boxes would be equal. They have the same dimension. But since I'm using the equals method that was inherited from the object class, I know that this will return false. And my results are as expected, false, false. The equals method just compared the addresses of the objects and they were not the same, so equals returned false. Well, that doesn't do us any good if we want to compare boxes and have boxes with the same, let's say, volume be equal. So we're going to override the equals method in the box class to provide our own specific implementation. When overriding the equals method, the header has to be exactly the same as it was in the object class. So here again is the equals header. Public boolean equals object obj. The reference variable name doesn't matter, but the boolean equals an object has to be the same. So again, I'm going to copy the header exactly as it's defined in the object class. And when my box object runs the equals method, I'm going to pass it another box object, and then I'm going to compare the volumes. And if the volumes are the same, I'm going to return true, otherwise return false. So my implementation will run the getVolume method in this object, and it will compare it to the result of the getVolume method in the object that I've passed. So So let's go ahead and compile and see what happens. As you can see, I get an error. Cannot find symbol, method get volume. That's because I've passed a reference, and Java thinks that that reference was created from the object class, and the object class does not have a get volume method. So I'll put box in parentheses in front of the O, but I need another set of parentheses before the dot operator. This will make O look like a box, which it is, and O can access the getVolume method defined in the box class. So I compile and I have no syntax errors, so let's run our test program again. And you can see this time when b1.equals b2 is run, I still return false because they have different dimensions. But when I run b1.equals b3, those two box objects have the same dimensions and the same volume, so that method will return true. I've overridden the equals method that I inherited from the object class, and I provided my own implementation that makes sense to test to see if two box objects are equal. So now let's take a look at the toString method, which is also inherited from the object class. Remember, to print out our object, we can put the reference variable name in a println statement. So since I do not have a toString method written in my box class, I'll be running the toString method that was inherited from object. So you can see the toString method of the object class prints out the name of the class, which is box, concatenated with the @ symbol, concatenated with a hash code value. This is really meaningless when I want to print out a box object. I don't really care about that information. What will be more meaningful to me is probably the dimensions of the box and then the volume. So let's override the toString method in the box class to print out the dimensions of the box and then the volume. And remember, I do not have to explicitly run the toString method. When I print the reference variable in a println statement, it automatically invokes toString. This would be an equivalent statement. I could explicitly write .toString to invoke the method, but I don't have to. And here is my implementation to override the toString method that was inherited from the object class. I'm going to return a string with the length concatenated with an X symbol, the width, an X symbol, a height, and then the word volume, colon, and then I'm going to run the getVolume method, which will calculate the volume and then concatenate that to my string. The header of the toString method must match exactly the header of the toString method in the object class. The headers must match in order to override the implementation of an inherited method. So you can see when I execute my box test program, the toString that I created in the box class is now being invoked. I've overridden the toString method that was inherited from the object class. So this representation of a box object is more meaningful to me. So the equals and the toString methods will be methods that you will want to override when creating classes of your own. In this tutorial, you learned about the object class in Java. You learned that all classes are descendant from the object class. And you learned how to override the equals and toString methods inherited from object in the classes you write.